party started. Gonna go and announce it on the stream plan. Okay. It's the next to last day of Advent of Code 2021. HTTPS twitch.tv/Raimu. Alright. Oh, I have the quality options. That's nice. Hello, internets. We're going to do Advent of Code Day 24, 2021 in 4 minutes and 46 seconds. So let me prepare. Starting a little bit late. I probably should have gotten ready like 5 minutes ago, but hey, you know. I had my shows to watch, so, you know, that's why I'm cutting it close here. That's okay. I'm going to bet that the input is a string. Whoops. I don't want to replace all of that. Hold on. Just that much. Alright, and then we're going to go all the way down to part 1. Down to there. Replace all this. Oh, all this lovely stuff here with to do. Same here. Hey there, Devil Squirrel. What shows? I was watching Wheel of Time, and then I started watching The Expanse, and then I'm like, oh, I gotta stream soon, so I'll watch The Expanse later. Let's see. I can write this. This is just a string, right? Today's drink of choice is Old Rasputin by North Coast. This is a Imperial Stout. It's like one of my favorites. Russian Imperial Stout, actually. Okay. My day 24. We're almost done. Almost done. I got 3 minutes to go. 24. I don't have a 24, but didn't have a 23.txt because 23 didn't have a real input. Also, the benchmarks probably don't work for 23. How's everybody? Hey there, Eric Wassel. Thank you. You too. If you're doing Advent of Code, good luck to everybody who's doing it. So what is Advent of Code? We're going to do day 24 of it in 2 minutes and 43 seconds. It's an Advent calendar of programming challenges. You usually get 2 parts. They're related to each other. Sometimes part 1's easy and they slam you with part 2. Other times part 2 is a cakewalk because you went that extra mile and designed your part 1 really well. So it's Christmas themed. This year's theme is we, whoops, dropped the keys to Santa's sleigh into the ocean. So we got to get in our submarine, go all the way down through underwater caverns, down this trench to the very bottom where hopefully we find those sleigh keys. Otherwise, we're toast. So you can compete on time. It's very competitive. I've never been able to get a score on it last year or this year. I almost got some points 2019. This has been going on since 2015. Just go to adventofcode.com. You did it last month? Are you doing OC? Oh, you did it last month. You mean like 2020 last month? Yeah, you don't have to do it on time. I like to do it when it unlocks just because it's sort of competing. Not on points, but on rank. I don't know. It's a great motivator, right? Let me make sure that this thing builds. I don't want like something silly like a building problem getting in my way. It should say it's not implemented yet. I have a minute and a half. Uh-oh. What did I do? What did I do? Oh, no? Input doesn't exist. Because this actually needs to take a string. Okay, now it'll run. And it should say not implemented yet. Because we haven't implemented a solution to a problem. Oh, no, unknown puzzle. That means I haven't put a main in place. I can do it. Last minute. I can hear that last minute warning going off. There we go. Not yet implemented. So this unlocks along with same unlocking for everybody. Midnight Eastern Time, which is in 40 seconds. What was day 20 again? I thought day 19 was evil. Day 19 was evil. Day 20, Okay. It had an evil twist in it, but if you could manage to spot the evil twist before you got too deep, then it wasn't so bad. But I see what you mean, though. 10 seconds. Hey there, egoist. Did I say hi to Code Monk? I don't know if I did. Hello. 3, 2, 1. Let's go. Arithmetic logic unit. Magic smoke starts leaking from the submarine's arithmetic logic unit. You know, magic smoke, you don't let the magic smoke out. That's the rule. Without the ability to perform basic arithmetic logic functions, submarine can't produce cool patterns with its Christmas lights. It also can't navigate or run the oxygen system. Don't worry, though. You probably have enough oxygen left to give it enough time to build a new ALU. It's a 4-dimensional processing unit. It has integer variables W, X, Y, Z. Its variables start with 0. It also has 6 instructions. The sound is starting to sound like we're making a virtual machine, doesn't it? So it has some instructions. And all these instructions, A and B are placeholders. A will always be the variable, while the result of the operation is stored, one of X, Y, W, and Z, while B can be either a variable or a number. Numbers can be positive or negative, but will always be integers. The ALU has no jump instructions. Every instruction runs exactly once in order from top to bottom. It halts after the last instruction. Program authors should be especially cautious attempting to execute divide with b equals 0, or attempting to execute mod with a less than 0 or b less than or equal to 0 will cause the program to crash and might even damage the ALU. Don't let the magic smoke out. These operations are never intended in any serious ALU program. For example, here's an ALU program that takes an input number, negates it, and stores it in X. Here the program takes two numbers, sets Z to 1 if the second number is 3 times larger than the first number, and sets Z to 0 otherwise. Input Z, input X, multiply Z by 3, equate Z and X. Okay, here's a program that takes a non-negative integer as input, converts it into binary, stores the lowest 1 bits in Z, second lowest 2's bit in Y, third lowest, etc. Yeah, because it's doing modulo and then div. Okay. Once you have built or replaced an ALU, you can install it in the submarine, which will immediately resume what it was doing when the ALU failed, validating the submarine's model number. To do this, the ALU will run the model number automatic decoder program, Monad, your puzzle input. That's a clue if I've ever seen one. Submarine model number is always 14-digit numbers consisting only of digits 1 through 9. Digit 0 cannot appear there. It checks a hypothetical 14-digit model number. It uses 14 separate input instructions, each representing a single digit. So to check the model number 135, blah, 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 you would give 1 to the first 3. Okay, I got it. Then after the Monad has finished running all of its instructions, it will indicate that the model number is valid by leaving a 0 in Z. However, it's invalid, it will leave some other non-zero value in Z. Monad imposes additional mysterious restrictions on model numbers, and legend says that the last copy of the Monad documentation was eaten by a tanuki. You'll need to figure out what Monad does some other way. To enable as many submarine features as possible, find the largest valid 14-digit model number that contains no 0 digits. Okay, they lost me somewhere around when they were talking about the model number. Let's get our puzzle input. Okay, let's copy and paste into 24.txt. Close it up. What kind of example did they give me? And what are they looking for? The largest model number accepted. So I really can't use these to test, can I? So there really is no test. Well, so much for test-driven development. I think I understand. We're supposed to write a virtual machine that takes a program like this, which is our input, and run the program on different numbers to try to figure out the largest one that'll be accepted. So I think we're studying programs, right? So the largest possible is all 9s, right? I have no idea how to approach this problem. Oh, wait a minute. Hold on. This is all for part 2, I think. We just need to find the largest valid 14-digit model number that contains no 0 digits. Oh, one valid number. Like, if it's just the largest number that contains those 0 digits, that's easy. But why did they have to put the word valid there? So the 14-digit number is way, way too expensive to brute force it, right? I suppose we could look for patterns. So first we have to write the damn thing, right? So let's do that. Actually, that's how we can write these tests, right? We can write tests around these in succession. So let's make this one. We have to have both a program and an input. So let's have a program and then the input of, what is it? It's always numbers from 1 to 9. Sure. Okay. So this isn't going to be part 1 inner anymore. It's going to be just testing the execution of a program, right? So we can say something like let monad, I guess, equal parse monad. Okay, and then assert equal -5 for monad 5. And we might have multiple inputs. So what if we feed it a slice of some kind? Or if we know that it's going to be taking it from most to least significant, I can put in a string and it can just figure it out most to least significant. There we go. Okay, so another example, like actually that's fine. We'll just leave it at that. Well, no, one more so we can have extra validation here. Hey there, a squared 31415. Let's test the slightly more difficult monad. Right there. And they said that this one sets z to 1 if the second is 3 times larger than the first. So is z our output? Oh, we have a problem, right? I can't just use the output. What if I do assert matches? Because they said we have 4 variables, right? What if it just pops the variables back out at us? So x, y, z, w matches. Put monad 5 on the left and this on the right. I need to define monad before I go much further. So struct monad, and I'm not going to have calling it. Let's just say run. That should be -343, right? Some kind of monad, capital M, thank you very much. And then, what if we just call this monad new? That way I can just have an impl monad, function new, input, string, self. And for now, we'll just keep it empty. And then we'll have a method called run, which borrows a self, returning a tuple of numbers. I'm thinking if I should make another type out of that, because that's going to be kind of clumsy. It should be fine. It's fine. Just to make sure that this, so I don't have this correct because there's too many parentheses there. And I don't have enough parentheses over here. Okay, what's wrong with my run? Oh, I need an argument. Yes, I need an argument. Run takes a input. So let's not call this input. Let's call this source. This is input. Okay, so that works. I wanted to call that monad new instead. The inlay hint is screwing this up, isn't it? Yeah, that's okay. And then, yeah. Here they said that z, so x, y, z goes into here. So let's say it's a 1. They said if it's the second number is 3 times larger than the first number, so the first number being like 1 and then 3, right? And then the alternative would be like 2. These should be, I said, these should be ignores. Because we're looking at the z now. So that's a 0. And that's a 0. But like 3 times 2 would be 6. That would be a 1. Like that. That's a good test, right? Okay, what's this one? Okay. Another monad. With that source. I just want it to line up. There we go. Takes a non-negative, oh yeah, they're all non-negative integers. Converts it to binary, stores its lowest 1 bits in z. Oh, 1's bit. Why order it z, y, x, and then w? Isn't the normal order x, y, z, w? Okay, whatever. Sure. So to get like if we took the number 6, for example, the lowest is 0, the next lowest is a 1, and next lowest is a 0, and the highest is a 1, right? Why don't I just do that for all the first, I don't know, 9 numbers or so? Are they real monads? I don't know. I think so, but I don't know what a monad is, so yeah. I don't know. So this is the 1's bit here. The 2's bit is in y, so that would be 0, 0, 1, 1, 0, 0, 1, 1, 0, 0. And then the 4's bit is in x, right? They said, right? So that would go 1, 1, 1, 1. And then W being the 8th bit. There. Okay. Let's just focus on getting the monad type to work. So the new here. Run is just going to go through a sequence. So I think we just want to make something called an instruction. And that's going to be an enum, right? And they give us several kinds of instructions. They said we can have an input. And we have a variable, so let's just keep that an index. What I'll do is I'll have variables in here 4 of them. Like that. And this will index them. Okay, add. A is always a variable. B can either be, either a variable or a number. Okay, so then I need another kind of thing. Enum, second argument, variable or number, right? Okay, so then we have here an add and a second argument. Tuple, so I need to have an extra parentheses, and then multiply, divide, mod, and equal. Should I just keep it simple? Just as many characters as they gave me. Mod and equal. Okay. All right, and then we need the instructions. Instruction. All right, and then so the vars will be, actually we don't store them here, right? That's something that the run holds on to. So really it's just instructions. Source.lines.map line to line.trim. And then we're looking at the first 3 characters, right? Is it always a single digit number? I could look at the 24.txt to see. No. In fact, we have some negative numbers in there too. It is kind of easy to parse because we just look at the first 3 characters. We look at the 5th character, and then we look everything from the 7th and on to split it. So I don't even need to really do much to split this thing. Map the line to, actually this can just be string trim, right? And map the line to an instruction, really. Let var equal match line 0, 1, 2, 3, 4. I hate assuming it's ASCII, but this should be fine, right? It's going to be either X, Y, or Z. So X, I chose to be 0. Y1, Z2, and W3. Everything else should be unreachable. Let's just put in something, a filler here for now. Instruction input 0 or something. And this needs to be collected. I need to do that. I forget how to slice like this. What am I missing here? Interesting. It doesn't like line for some reason. Line, a slice can't be indexed. Okay, fine. I'm doing it wrong. It's line.chars.nth 5, I think, right? 0, 1, 2, 3. No, it's fourth one. Okay. And it better be something. So there we go. So we get our variable off of there, and then these are all quite alike, aren't they? I almost think I should put that into another type. That would be really useful. Let's do that. So op arguments, not an enum, struct. So we have var, which is use size, and we have, or just left-hand side, right-hand side, second argument. So these are all that. Then I can parse that next, if it's not an input. So we'll just make a special case for if line. I thought you could slice a string, but I guess I'm wrong. Why can I not remember this? What am I doing? I don't want to look it up in the book. I want to say, well, is there a substring? Rust string substring. Yeah, that's what I thought. Oh, it's a dot dot, not a colon. Colon is for Python or something else, right? Yeah, okay, never mind. So it is a 0 to so the number of things that I want, right? 3, 4. Is it imp? Imp. Else. Then it's instruction imp var. Else we want to parse the second argument first. So let arg equal what doesn't like this? Oh yeah, slice it. There we go. And then let arg equal line. So this could just be 4 to 5, right? I mean, I think it's easier to read. I'm having trouble counting tonight. 0, 1, 2, 3, 4, 5, 6 on. Dot parse dot unwrap, and then match line 0 to 3. They're all up here. Oh, what am I doing? I should make the args equal op arguments var. What did I call it? Should just call it arg. Oh, left hand side, right hand side. Left hand side is the var. I can close this. Right hand side is the arg. And here it's add args. Instruction. So there's mul, there's div, mod, and equal. So they're all kind of like this one. Mul, div, mod, and equal. Anything else is unreachable. Incompatible arms expected. What is it saying? What? Oh, because of this. Get rid of that. It needs to be a slice, really? Okay. What's wrong with this one? Mismatched types. Found a reference. There. What's it not like about this? Oh. Shoot. It can be an X, Y, or Z, or W. Right. So I need to do a match first. Yeah. Match that. If it's some arg, then it's second argument. How come it's not telling me? I see variable. Did I call it number? Why did I do that? It's capital number. Number. And that's arg parse unwrap, comma. Alright, so then it's these same X, Y, Z, W's in front. Only in front of this is second argument, variable, and then that. Okay, I did it. Now we have to do the running part. So we let mute vars equal this tuple, and at the end it's just the variables, right? And then let's just let the input equal input into, well, chars. Yeah, just chars. Iterator of characters, right? So for instruction in self.instructions, match instruction, input var, it is vars input.next.unwrap.parse.unwrap that's the input. Vars var equals that. Cannot index into a value of that. Oh, I need to do a dot. Okay. Really? Okay, fine. Then I'm going to make it an array. Screw you, Rust. That should just be a 0. Go back to using the indexer. I forgot that you can't use a variable to index a tuple. I guess it makes sense, right? Because they could be different types. No method, name parse for type character. Is that just because it doesn't know the type? Chain all the things, I know. I guess you can't parse a single character as a number. So then I will just take that and add, well, subtract from it binary 0 and then convert it into a usize. Right? As a U8. There we go. Okay, so then each of these is a args. So then add and we have to do a match on args dot right hand side, right? We need to borrow the instructions. We're not going to mutate them. If it's a variable right hand side, number right hand side. So if it's a variable, then it's vars. Why is this index not working? Oh, I need to. I guess I can do that, right? No, I can't. We'll just dereference then. Fine. Add just puts it back into it, right? Let's see what it says. Add value of A to the value of B and store result into A. Okay, so that's plus equals vars right hand side. I don't have, oh, it's args left hand side. Okay. If it's a number, it's slightly different, right? Then we just add the number. Easy. Why can't I do that? Oh, these need to be eye sizes. There we go. What's wrong with... Oh, yeah. That's why. Types have to be consistent, right? Okay, so... This really, we need to copy 4 times and modify it a little bit for each one of these, right? Slightly different ops going on. So for a multiply, it's multiply. Divide is divide. Modulo, it's modulo. Equals different. If they're equal, then store a 1, otherwise store a 0. So if they're equal, then vars args left hand side equals 1. So turning that around, else 0. And that, for a number, it's just right hand side. Okay, I have a, all right. We have to turn this into a tuple. So it's vars 0, vars 1, vars 2, vars 3. Let's run our test. Let's see if we have a functional machine. We do. First try. Functional machine in 31 minutes. Now that we have a functional machine, we have to figure out what to feed it to figure out the largest we can feed it such that we get a 1 out, right? They said, what did they say? Oh, if we get a 0 for Z, it's valid. So what if I just look for patterns? So we would say let monad equal monad new input. And let's just try like for n in 0 to 100. And we say let, I don't care about the other numbers. We only care about the Z. Equal monad dot run. And then I need to put n into, oh, we can't have zeros in there either. So like 1, 2, 3 would be the smallest number if it was 3 digits, right? To like, I don't know, let's just go like 20 or something to like 400, yeah. And I guess we'll skip it if it has a 0 in it. So let n equal n to string if n dot chars dot any c equals 0. Continue. Monad run in, borrow in, and print the answer. And at the end, we're gonna print something. So let's just do 0 for now, just to make it happy. And we'll print the input and then the output. That's n and z. That needs to be a function. This needs to be to string, or to owned, really. It's already a string. Let's see what I get. So, shell, please. Cargo, run. That's already in my history. It panicked on unreachable on 38. So, something wrong with my parser. Okay. let's look at... Okay, do I have 24? No, I have 22. Should always check that, because copy-paste has killed me more than once. Okay, now it's on 77. Oh, I think we have to have enough input. Yeah, we didn't have enough input, so I guess I need to pick a really big number. What if we just pick all ones to start with? Did they say 14-digit number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, yeah, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Actually, we'll do this thing we can do in Rust where we can put separators in. I'm off by 1. I can solve that by doing that. And we'll just go like 20 or so. Literal out of range. Well, let's make it an I64. So, or I size, I guess. That really screams to be called a 64-bit number. Oh, that's interesting. That's a very large number for Z. So none of them are valid. I think I want to print out more, though. How many more? Put a 3 there. How about we just put 9s? Let's print the first 1,000. I guess I'm looking for a pattern here. Hola, Endurin. Happy Friday morning. Happy Christmas Eve, too, for you. Clippy has a lint for using underscore wrong. For example, if you tried 10 underscore 00 1000 but wrong. Oh, it does? I did not know that. Let's see this in action. So you're saying if I just did that. Oh yeah, look at that. Digits group inconsistently by underscores. Cool. Before the alarm goes? You mean you're still in bed? Wake up, Andorn. Actually, you don't have to work, so go back to bed. What are you doing watching me? Shouldn't you be sleeping in? That's what I do on days I don't have to work. I guarantee I don't have an alarm tomorrow. I'm sleeping in. It's a holiday. I really don't know how to approach this because they say there are mysterious restrictions. We need to figure out. How do we figure out? Just experimentally? I mean, I guess so. We just have to run experiments. So, what do we notice about these numbers that I told it to go through? We like get a smaller number every 11. Every 11 we get a smaller number. Okay. So then what if I start at this one and just add 11 each time? Can I do that easily with this? What am I trying to look at? I'm trying to look at this at the same time as I'm looking at that. Just give a range as an answer totally works. If there's a cycle every 11... Oh, also the lower digit walks through a pattern as well. See that? There's a pattern there. It's walking, it's advancing by 1. And here, look at that. Here it got even lower for a second. I have a hunch. Is it giving me a factor, like a largest common factor? What if I take this number and divide by that number? What do I get? Calculator, please. So, Indurn, although it's morning for you, it's evening for me. That means I'm drinking. So I'm having a Russian Imperial Stout called Old Rasputin tonight. So I might be a little under the influence of something. Well, of a legal substance. What if I put in that number and divide by 1094640? Okay, that did not give me another whole number like I was hoping. I am a real programmer, yes. These just look to me like they might be factors, but maybe not. That last digit walking looks suspicious to me. It repeats after 20, right? Every 20 it repeats. Do I see that pattern again if I keep scrolling down? I don't think that pattern happens again. It's only in that one spot. Right there. Right here. What's special about that? I'm not allowed to feed it zeros either, right? Each input structure should only ever be given a digit value of at least 1 and at most 9. Yeah. No zeros allowed. Best code is written drunk. I haven't written code drunk very often. I mean, alcohol is supposed to lower your inhibition, so if I have an inhibition against writing code, this will help with that, I guess. I'm trying to learn more about this pattern. Like, here's something funny. That number there. Why do we not have 739976852 here? Are these related? Are these two numbers related to each other in a certain way? So what if I took this and divide by the other number? I meant to put that in the clipboard. See, I think just drinking alcohol means I have a propensity to make more typing mistakes. 606448. 8. 2.6. Very close to 2.6. So if I want 28460648 times 2.6, I get a number very... Oh, wait a minute. I typed it in wrong, I think. 739,976,852 divided by 28460648 equals... Oh, 26. 28460648 times 26. Okay, so there's a factor of 20, almost 26 involved. So this is 1/26th of the number that should be between these two numbers. So maybe I'd write these down as hints. This is kind of fun. It's like a detective thing. So clues. What happened to my output? That was weird. I bet you this and this are related by a factor of 26. 0644 divided by 109 is 4640. It's that 26 number again. 26? What is this number divided by 26? I wish this wouldn't disappear on me. I mean, those aren't related to each other in any way at all. I typed with the first number, yeah. I forgot the 1, yeah. I figured it out. It's 26. There's some factor of 26. I bet you that divided by that is 26. Right? Actually, that we already knew that, right? 399,76859 divided by 26 is pretty much that number with a little bit off. Okay, so there's a mysterious 26 in there. Also, it repeats itself every 20, right? Actually, every 10 it repeats. You know what? That last digit is repeating itself, but these other digits seem to be constant. I just noticed something. For all of these, if you just take that last digit, it's 1 minus that last digit. Except for this one where it's 1 plus. You're not going to approach this at the other end and just study the program to try to figure out what it's doing. That's another angle we can do. So another clue is the increasing last digit of input increases last output digit, but does not change any of the other output digits. Except for sometimes the output is divided by 26 to the power of n. So we've seen n 1 or 2. I hit save. I didn't need to do that. So that means you might be able to change the input to more human reasonable. For example, that. We have to have 14 digits, and they have to not have any zeros in it. So the lowest possible number is all ones. That's the lowest. The highest is all nines. Yeah, no zeros allowed. So I'm actually skipping zeros with that extra bit of code I put in right here on purpose. I tried a small number of digits, and it panics out of input, underflow on input. So, you know, I could play with making these all nines instead of ones and go... Can you go backwards in a range? Actually, the other way to do it is just make these all nines. I should have just left that as all nines. Make these all ones. Let's look at the end of the input. Let me get a sampling of this to put in our clue book. Like maybe just these first ones. These are the clues. Let's save this as clues.txt. All right, and then let's try it again. Look at the very last numbers. Okay, that's probably still 26, right? 2, 7, 3, 1, 3, 6, 9, 6 divided by 26. No, it's not. So what's the difference there? 1, 2, 7, 3, 1, 3, 6, 9, 6. No, it is 26. I just keyed it in wrong again. $26, yeah, so it's a factor 26. Is it every 26 we get one of those? No, here's where it's off by 11. Was that true in the other one? It was every 11th one. And here's where it dips by a lot. Is that squared? 1, 2, 7, 3, 1, 3, 6, 8, or yeah, 8, 1 is where it should be. Divided by 4, 8, 9, 6, 6, 8, 0. Oh no, that's 1/26 again. Oh. Wait. This is 1/26 and this is 1/26 of that. There's definitely a repeating pattern in there. The very last numbers like these or something. So how are these numbers related? Not that window. Did I close it? I closed it. Why did I close it? My trusty calculator. I'm sorry, calculator. I didn't mean to close you. Scientific, please. Okay. This number divided by this number. What do we get? 4.47. Is that the ratio of these two numbers? Times equals. Nope, not at all. Maybe half of it. It's hard to say. Oh, dare I say 2.6? No, it's off. You can do range dot reverse. Oh, yeah, it's true. Surely that can't be a coincidence. You mean that we have the factor of 26 going on here? I should try to capture some of these low numbers that we find. Actually, does it get even lower than that? It's like the frequency of these dips increases and then decreases back up again. All right, I should study the program that we got. Here's the program itself. Hey, look, we got 26 in there. We got 26 in a fair number of places. In fact, I see a pattern here. Look at that. I think it's just looking at every input. How many inputs do we have? 9, 10, 11, 12, 13, 14. Exactly 14 inputs. Okay, so this is really the kernel of it, right? Input a number, multiply x by 0, add z to x, take the modulus 26, divide... Well, this is a no-op, right? We can toss that one. In fact, what happens... Well, this is... I can toss this instruction, right? It does nothing. Z divided by 1 will always be z. Unless did I misinterpret the instructions? Divide a by b, truncate the result to an integer, which I'm already doing. The store in a. Here, truncate means round towards 0. That's what we're doing. Yeah, that does nothing then. Multiply also feels like a version of XOR EX. Oh yeah, that just loads x with 0. Okay, I see what it's going. So it just says this copies. Okay, we can interpret this. We can reverse engineer this. This is probably the easiest way to do it, right? So basically, that means I don't want to save here either because it'll screw up my program. This is input W. Well, we know that. I don't need to write anything there. That's obvious, right? This is x equals z. This is x equals z mod 26. That's a no-op. Why do we have 2 equals in a row? This gets tossed, right? Oh no, it gets stored back in x. So x equals z mod 26 plus 12, right? So, and that was our last digit. So input is 26 plus 12. And then, oh, this reverses it, right? If x is 0, it becomes 1. If x is 1, it becomes 0. So this is not equal to. That's what that does. All right. Multiply y by 0. Just sets y to 0. Add 25. Okay, here's where... Okay. y equal 25. So then here, this means that y equals 25 times this. Plus 1. Right? And z starts out at 0, right? Everything starts out at 0. But I'm guessing it just repeats. So it's accumulating digits as we go. So it's the same program repeated, I think. I can highlight this to verify that. Why is it? Is it not unique? Oh, it can't do it multi-line. But I can do it instruction by instruction to see that these are all the same. Oh, no, the add is different. I see. So there's a 12 there. The second time through, it's a 13. And then another 12. And then an 11. Oh, it gets a little different down here, doesn't it? Yeah, it's different down here. Yeah, are we all collectively hacking the secure hashing algorithm? Yeah, I save out of habit. That's okay. I figure I'll just get it back. I'll read it back later. In fact, I should just kind of save this as something else. 24 reverse engineered. And then we'll get the original back. 24.txt. I thought I saved it. Oh, I saved it as, but it kept that one. Overwrite that one. There we go. Well, that does nothing. That just sets z to 0. That doesn't do anything. Yeah, I should take advantage of the fact that we know is 0, right? So that's just really 12. But input can't be 12. So then that means that, yeah, this is 0. Plus 12 is 12. Input not equal to 12 is 1. So that's 25 plus 1, which is 26. Always, right? Let me make sure I understood that right. That's 0. They're both 0 still. 0, 0, 12. 12 equal to input. Always a 0. That's a 1. 25 plus 1 is 26. Yeah, it's always 26. And then z is still 0. So wait a minute. This doesn't make sense. That will put it back to 0, so it tosses the first. So the first digit doesn't matter? That's what that's telling me. First digit doesn't matter. Should I test that theory? Where are my clues? If the first digit doesn't matter, then it won't matter if I change that back to a 1. But it did matter. Oh, maybe not. 77. It did matter. Okay, I'm lost then. Did I do something wrong interpreting this? Beep boop, alarm, time to get up, Endorn. Wake up, Endorn. I become an optimizing compiler, yeah. Okay, I don't understand why this input matters. Oh, because it's used down there. Ah, that's why. So all this accomplishes is just load y with 26 and then toss it, right? So these don't really do anything. Because 0 times 26 is 0, 26 times 0 is 0. This is the first one that accomplishes something. This says y equals input plus 1 and oh, I should have seen what x was. X is 12, 0, 1, x is 1, right? So, You know what would be easier is if I just have it print these out along with the 4 values of x, y, and z for every instruction that we do. Wouldn't that make more sense? I think so. So let me do that. So instead of... So we'll just try... so X that out. We'll just try one number. Monad.run 1 1. Well, I can still do this way, right? String. I64. And then in run we can instrument this, so we can say print line input to that. Vars var. Just print it this way, right? Let's print out that, and then right-hand side. Arg's left-hand side. Variables arg left-hand side, then right-hand side, and then var's right-hand side. And then we don't need to, we just show the value here. That without the equal. Then I can do a similar thing here. Only we don't need that. Okay. Need that for multiply also. And divide. And modulus. And equal. Well, equal is different. There's a shorter way to do that, this part, right? It's just to cast, it's probably going to tell me this, right? Unnecessary, no. It's not going to tell me. I think you can just cast a boolean to an int and it does that for you. I'm not going to worry about that right now, though. This is just, it's not a variable lookup, it's a literal. Okay, and then I need the literal multiply. And divide. And modulus. Modulo. Okay, let's run that. Okay, here's the step by step. So it's like I thought, right? Only I'm just letting the computer figure it out now, so I don't have to. Did I already close that file? I didn't delete it though, it's still there. That this is all basically a no-op. Oh, 3 was Z. Let me blow this up and look at the end. We want to get a 0 at each step, right? I think maybe that's the way I work this problem, is if we're trying to get a 0, let's see what the largest number can be at each step to end up with a 0. Yeah, the last one is an add that goes into Z anyway, right? I closed it. Yeah, last one goes into Z anyway. That's what that means. So it's these inputs that bring numbers into Z. It's always into Z, right? There's where that number gets in. Okay. What am I building? I'm trying to build a solution to Advent Code Day 24. So this Day 24 puzzle is pretty complicated in my mind because they first had us write a virtual machine with all these different kinds of instructions, and then they gave us a program like that, and then they said try to figure out the input to the program that gives you a 0, and not only any input but the largest possible input that will give you a 0 for the output. So I decided I would, after constructing this virtual machine, now try to figure out by looking at it, like, how do we get a 0 here in this output? You know? I wonder if people will work on compilers for this. It's a complete ISA. I hope they do. Yeah. Bool as int exists, yeah. Stepping the VM will make more sense. Yeah, that's what we're doing. Hey there, Crumpet. How are you doing? I'm looking back in chat and seeing some old chat there. So this is the number we want to drive to 0. It looks like we're always... Where's the last input? Here? Into register 3. We use it here. No. It says it's 0 there. What number did I use? Just all ones to test with? Yeah, we used all ones, right? So register 3 has a 1 in it. Oh, okay. Where is register 3 used? Here. So it had a 1 there. Okay. So the only impact it has is it equal to 3? Okay. That's the only impact that register... No, it's actually used down here again. We add it there. But here's the 20. We figured out that 26 is significant, and there's where, like, it comes out, right? So let's see if I can understand. This last digit, why does it roll over every time? I think it's because we add, at the very end, a number where it got included here. Yeah. So going back to the clue sheet, right? It looks like it's incrementing, and that's because of... oh, that's weird. Huh. Weird artifact there. Clicking to another tab and back fixed it. That's that last input step, right? It goes into register 3, and then there's the add of register 3 to a register that we end up adding at the very end. Thing that's throwing me though is there's all these like intermediate things that I'm trying to wrap my brain around. What is that virtual machine responsible for? This is the input we feed to the virtual machine to get this output. We're trying to figure out what's the largest input we can feed it to get 0. So I was looking at the patterns, just trying to random inputs, and it looks like it increments, and then all of a sudden it'll drop by a factor of 26, and then bump back up. And I think it's because there's a modulo 26 in there. It's weird. There's a modulo 26 and then a divide by 26. So that means it's putting the dividend in register 0 and the divisor in register 2, right? Yeah, this is effectively breaking up what was in register 2 into the dividend and the remainder if you divide by 26. So that's that pattern that we're ending up seeing. But that 26 shows up everywhere, right? Too much output to deal with. I mean, as we see, like these numbers keep growing, right? I think our goal would be to get them 0 all the way down the line. So our goal would be to get that to 0, right? So how do we get a 0 there? Change it to, well, how did that become a 2? That became a 2 because we added 1. So how do we get a -1 there? I don't know how. This is modulo 26. It's adding 12. It's adding 25 in there. To get 26. I don't know. Is it possible to solve this in reverse? Oh, that was a trick that one of the someone used in 2019, right? For one of these, you just reverse all these instructions. That's a good idea, actually. So if we say we want a 0 there, the problem is I don't know what the numbers in parentheses. There could be any two numbers that add up to 0. But can I just assume that there are not going to be any, oh no, there is a negative number. How do we get a negative number in there? Oh, that was literal in the program. Okay. So one of these might be negative. Otherwise, they'd have to both be 0, right? The actual hardware doesn't matter. It's just instructions. Yeah. But yeah, it's a contrived example. If you just go to day 24, you can read about it. It's a contrived example to try to get us to figure out. It's basically a puzzle to figure out, or figuring out the combination key to a puzzle. and I'm feeling like the end, it's going to be the largest multiple of 26 and some other numbers. Maybe it's like 26 to the 5th power or something, right? That would be a wild guess at this point if I just found what's the 26 to the n equals a 14-digit number and what it solve for n. So what are some ways to get a 0 in that position? Let's just assume that needs to be 0, that we need to get a 0 before every input, because it looks like it's just doing a little bit for every digit, and whatever number it gets, it carries on into the next, and it's just accumulating. So if we want a 0 at the end, we want all these intermediates to go to 0. So assuming that, then how do we get a 0 here? I should be able to look at that and reason it out, right? The first non-zero we get is this 12. This 12 was only used to compare with register 3, which had our input, if it's equal. But that's always going to be 0. There's nothing we can do. Yeah, we already reasoned out that there's nothing we can do. Those are always going to be 0. That's always going to be a 1. That's always going to be a 25. What's the only thing we have control over here? We don't have any control, because our only input is going to register 3, and the only thing that's used for is to compare with 12, which is always going to be false because the input can't be anything but 1 to 9. So what else do we have control over? Oh, here, we're using that input again. So we're always going to add 0 to our input to get our input. So our input goes here. And then we're always going to add 1 to it. So 1 plus our input. And then it's going to be multiplied by, I don't know why you would multiply by 1 always. That doesn't make sense. Okay, so that is our input. It's always going to add, it's going to always be our input plus 1. Oh, shoot. I'm not on our clue thing. So input 0 plus 1 is the this first block, we always get out our first digit plus 1. It's an approach that I think would be interesting, but I won't talk about. It might be far too much giving ideas methods. Yeah, maybe. Let's see if I get anywhere with this. So here's our next digit. Goes into register 3. And where does that get used? It gets used here. But our input starts to get used because it's in register 2 at this point. It's also in register 1. So it gets used here and here. I shouldn't forget register 0 has a 1. How did it get that? No, that's constant at that point. Okay, how did we get a 62 here? 52 plus 10. That 10 is something plus 9. I have a feeling that what it comes down to are these literals. We have to figure out how these literals are being combined, right? Yeah, it's fun patterns like, well, it's easier to look at it in the original instruction set, right? So when we look at this, like, this is just a roundabout way to load, well, this is to make sure that x is 0, right? Multiply it by 0, you get 0. This is a way to do an assignment. So this is just a clever way of doing that. This is just a clever way of doing that. This is mod equal 26. This is no op as far as we know. Why you'd ever divide something by 1, I don't know. This is an x plus equal 12. Again, I'm modifying the wrong one. I shouldn't do that. I shouldn't modify the input like that. It's just going to mess me up later. Okay, I give up with repairing that. Let's just go back and get my puzzle input again. And not touch that file anymore. The reverse engineered version. X equal to input 0, the first the 0th digit, right? And this is just x equal not x. And this is a y equals 0, y equal 25. Yeah, so this is really x equals z mod 26. So then this becomes x is z mod 26 plus 12. So then this becomes x is not equal to input 0. This is y equals 25 times x. So, which is either going to be 0 or 1, right? Depending on if our input is 12, which it never is. So this means y equals 25 times x plus 1. And then we already knew that z is 0. So this is all no op as far as we know. Z is still 0, right? And then this is another y equals 0. So really y equals w. So really y equals w plus 1. So really, and what was w again? It's our input. So this is really y equals our input plus 1 times x, which is which is 0. X equals still 0 here, right? So here x equals 12. But then we said that this is always 12 equals input, which is always a 0, which is always a 1. So x, which means basically just that. Y equal our input plus 1. And then what significance z has? Z is still 0, so it just means z equals our input plus 1. So then we get our input 1 at that point. Multiply x by 0, just a clever way of saying x equals 0, and then this is x equals z, which z is that. So this is that mod 26. This is a no-op. Z is still 0. No, Z is still that. So it's x equals that plus 13. Maybe I just keep doing this till I get to the end. I'm kind of figuring out by hand if I do this right. So this is just x equals that equals input 1, which is always going to be false, right? Because anything plus 13 is always not going to be equal to a number from 1 to 9. So I don't know. I think this is just meant to confuse me. So this means x equals 1. Y equals 0 again. Y equals 25. Y equals 25 times 1, so it's still 25. Y equals is 26. Multiply z by y, so that's 26 times whatever z is. This one. Times 26. Y is 0 again. So really y equals w, which is input 1. Y equals input 1 plus 9. Okay, y equals that times x, which is 1. So what was z again? I'm losing track. Z equals this, right? Yeah. Plus this. Let's compare to the output at that point. Where's the plus 9? Here it is. So that's 1 plus 9 is 10 times, yeah, so that's 10. And then 62, right? Because it's 2 plus 10. No, hold on. That's a 52 in there. I missed something then. There's a point where we had a times 1 would have a 26 in it. Okay, see, I already messed it up. Oh, I think it was here. Yeah. So that's 52 plus 10. Yeah. Using a cover on a windy day? What are we looking at? Well, of course I know him. He's me. Knew the maker's first name was Eric? Yeah. And he's into Perl. Yeah, you're the creator of Advent Code. Looks like at least one person on the Megathread did figure out at least one. Oh, so Eric Wassel, you're the creator of Advent Code. I love Advent Code. It's knocking me flat on the floor today, just like on, what, day 18, I think it was? The last day, 25, usually is nice to people, but the next to last days are pretty rough. Actually, I'm curious to see, like, 22 was really rough on, no, 23 was really rough on a lot of people. See, it took me 3.5 hours and I still got a pretty low rank. How are we looking? Okay, some people did get it, but yeah, we're getting to the hard problems, I think. Oh, and someone told me yesterday that you can block off the ends of the side corridors, and it worked for me. But someone else I talked to said it did not work for them, so I was lucky. I should have just taken that as like a given. All right. Just knocking a non-zero number of people on the floor. Yes, that's what these problems are all about. I've rage quit one day. I can't remember, what was that, day 19? I rage quit one of these days. I think it was 19. Yes, I rage quit this one. I could not figure it out. And then I watched someone else struggle with it just like I did. And then I went back to it later and I did it off stream, which sucks, but I ended up getting the answer and it made me feel really good and really bad at the same time because I solved it, but I didn't solve it during the stream. So when we got to, I think it was 21. No. One of these, like, I refused to give up on stream. Was it 22? Yes, this one. So I almost rage quit 22 because I was on the right track, but I just couldn't find the last little piece of information. So I decided, since I mostly just enjoy implementing and I'm not one to kind of come up with the most clever algorithms, I'll just find a little hint online. And I just went through the Reddit mega thread for this one and I purposely didn't look at code. I just looked at ideas and I found an idea that was pretty close to mine and it gave me that missing piece and then I went and solved it. I wish I could have come up with that on my own though. Oh, you were there when I rage quit? I need to mark that VOD as like, watch this only if you know in advance that I'm going to rage quit, because it would be such a letdown to watch it and then have me suddenly quit. So I have a feeling that I'm going to make a lot of mistakes trying to figure this out. And so I shouldn't continue all the way down. I need to approach this a different way. 26 and 25 keep popping up. What can I do with that information? I'm not a numbers person. But we keep dividing by 26. What if with my trusty calculator, I just type 26 times 26 times 26 times 26 times 26 until I get a 14-digit number? How many is that? One more? 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, but one more and I'm not going to have too many digits, right? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Divide by 26. Didn't we say that the first digit shouldn't really matter too much? I don't know. What if I just take this number and decompile or run it through that? Put a 1 in front. I mean, what do I have to lose? Let's see what I get. It didn't compile because it doesn't have the shouldn't it just like figure that out? That's the only way it could work. I guess there are other types it could be. No. Well, look. The number stayed low a little bit longer. We got a 66 at that point, but then started to creep up again. Okay, why would it creep up at this point? I mean, there's 25 in there as well as 26. Yeah, I don't know if I'm going to solve this one today. The number is copied wrong. Did I copy it wrong? With the 1 in front, right? Maybe I don't want to add a 1 in front, but I have to put something somewhere, and I can't have a 0. That's the problem with this one. I don't think it's the number itself it has to be 26. I think it's each digit is going into a little bit of a kernel, and I have to like try to figure out what it's doing. What each kernel is doing, but this is where I think I'm stuck. This one doesn't appear to do anything but add 1 to the first digit. This one takes the first digit times 20, well, plus 1 times 26 and adds. Okay, maybe that 9 is significant then. This these numbers and this number are significant, right? The add 1, multiply by 26, and add 9. But I guess the magic part is I don't see how I would end up with 0 at the very end. Get the I-64 from the I-64 by mistake before? Yeah. I don't know. Maybe at this point, just like day, what was it, 22, I start looking at hints. I feel that though this one, once we get the hint, it sort of just like spoils the rest of the problem, because I'm not. How can I write a program to solve this? It's not the program that's solving it. The program's just verifying that I figured it out. This one's less of a programming problem at this point, right? Yeah. I think I'm about to give up on this one. Look at some ideas. Look at Reddit. I don't know, is this too much cheating? To look at the mega thread for it? I kind of feel like it is a little bit. I don't want the solution, I just want like a hint. Oh, maybe I should have looked up the hint. What is a tanuki? I must know now. Japanese raccoon dog. Okay. That probably doesn't help me out any, right? Alright, never mind. Stack of integers from 0 to 25? So, do I need to think in terms of base 25 or something like that? I thought about doing this too, that we take those constants out, and yeah, this is what I was trying to find one that ends up with 0 at the end. Okay, maybe I should try this approach then. What do they mean? The constants that were different for each input digit. Are they saying that this and this are the same except for some of the constants in the middle? Mul add. Oh, yeah, actually. No, there's an add equal multiply add 2 multiplies 2 adds. Oh, it is the same. Is it the same throughout? Okay, maybe I can figure out something with that from that hint. Well, that was your idea for the hint? Is that these are all the same program with different constants? That might be enough if I could just figure this out. Brain, work! Okay, let's see. The constants that are different. That 12 became a 13. There's a 9 there instead of a 1. I think I got that. I extracted out here, right? That 26 comes from there. This 9 comes from there. There's also a 13 in there, though. but I think I discarded the 13 at one point because of this being 1 to 9, it'll never be equal to 13. But maybe in some of the other things, it's lower than 13. Like, so I'm looking at the add after the div. 12, negative 13. Okay, there we're getting somewhere, right? 11. I need to break this up at the inputs to see it. Input. Negative 5. Negative 6. Okay. I think... Are there just the 3 then? I'm looking at that first multiply. Is it always a 0? I broke it up badly there. Why did I do that? No! Treacherous hands. Why did I do that? Probably the beard did that. I didn't do that. Ah. So, do you guys find it really frustrating to watch me fumble around with this problem? I think I would be frustrated watching me try to do this. Why don't I just list all the constants? 0, 26, 1, 12, 0, 0, 25, 1, 0, 1. Right? Second one, 0, 26, 1, 13, 25, 1, 0, 9. Some of them, there aren't enough numbers. I missed 2 numbers somehow. What did I do wrong there? 0, 26, 1, 12, 0, 0, 25, 1, 0, 1. So 26, 1, 13, there's 2 zeros, so I forgot. Diff time? It's a little hard because you're going about it in a way that you wouldn't. It's just a different approach. Yeah. I'm just listing all of the constants now so I can see which ones are actually constant and which ones are like coefficients to something else. I'm pretty sure that first 0 and probably that 26 also are constants. There's an 11 there, okay. Starting to see a little bit of a difference there. 0, 26, 26 instead of a 1. Ooh. Negative 13. 0, 0, 25, 1, 0, 6. Is this going to be some kind of like matrix or taps list or something at the end, and I'm going to end up wishing I had remembered calculus? Just carrying the taps, as I'm going to call them right now, because it makes me sound smarter. 25, 1, 0, 13. Where am I looking? Above, right? 0, 0, 25, 1, 0, 13. So, looks like we have 3 numbers that are changing. All the other ones are constant, but I'm more than halfway through, so I might as well finish. Sunken cost fallacy, don't fail me now. 26, 12, 1, 12, 0, 0, 25, 1, 0, 5. If I could understand this kernel then, and then taking the constants, I think I have an approach where I would write a program that just goes through all the possible combinations. just like the other day, I feel like I'm on some kind of track, and I'm hopeful, and I really hope it doesn't just lead in pain and suffering. 25.102. I'm on the track, definitely. Good. Good. That makes me feel better. My goal is to finish this and have enough time to play Valheim. The other day, I'm looking forward, like while I'm at work, I'm looking forward to just chill and relax and play some Valheim after Advent and Code. And like Advent and Code ended, I'm like, it's 1:30 in the morning. Must sleep. So, if I could finish with enough time to play a little bit of Valheim afterwards, that'd be sweet. You know, the other thing I can do is, now that I've extracted these constants, maybe this becomes the new input of the program that's actually solving the puzzle. Rather than having the code extract these numbers, since I've already extracted them by hand, as long as I extracted them correctly. So I've done two things. I've extracted the constants that really matter, which I think there are 3 of them per kernel here. And I've ruled out all the other ones. So let's take that to the top of the program just because I feel like it. And I think we're going to study this kernel here. Okay, we're going to understand this. This is all we really need to figure out. And I think what I'll do is I'll put a marker on all the lines that actually have a constant that matters. And we're going to assign them new variable names. Let's think about it that way, right? So some of these really are constants, but some of them are actually variables, like I is a variable. That's our input. This constant is always 0, so it's always going to be x equals 0. And then we're going to add z to it. I think z is our carryover, right? Yeah, so z is always the previous kernel's output. Figuring things out. So x equals, let's call this I of n, and we'll call this O of n minus 1. Okay? And then so x equals O of n minus 1 mod 26. And then z equals, this is a no-op. Pretty sure. That's thrown in there to screw us up, because that's always a 1, right? Oh, wait, no, it's not. Hold on. That's our first variable. Z divide equal capital A. That's our first actual variable for the kernel. And then x equals this plus 12. I should put the spaces in there. I'm going to go crazy if I don't have the spaces. Okay. And then is x equals a comparison of this. Well, comparison's always higher order, right? In I of n. And this is really just saying, is it not equal to? This is just a clever way of saying it's assign it to 0 and then assign it to 25, and then y equals 25 times that plus 1 plus, I guess. And then so actually I should have written this as z equals O of n minus 1 divided by a. So then z equals this times that. So then y equals 0 again. Y equals still I of n, right? y equals I of n plus 1. Y equals I of n plus 1 times this again. And then O of n equals, wow, that plus that. Okay, that's crazy. Where are other constants, though? There are a couple more. This one. Okay, so this 12 is B. Not but. Control D. B. The 0, 0, 25 is always there. The 1 and the 0 are always there. But this last one is our C constant. So that's wherever y is. There. There. Okay, let's check for errors. So, get our input. You missed one constant on the last line. Did I get that one? Okay, well I'll find the error if I did one. B equals 12. Oh, way over here. Oh, you're right. Thank you. This is too long, so let me reduce it a little bit. Ah, shoot. N minus 1. Wow. How am I going to think about this? The fact that we're doing an equals in there, and so we end up having a Boolean operation in the middle of our math is like crazy to me. Okay, well, let's take this monster expression and try to break it down, shall we? Divided by a times that plus that. Which is, yeah, I think that's it, right? Could put that in Wolfram and see how it simplifies. Never thought of that. I've never used Wolfram to do something like that. Wolfram. What are we looking for? Is it Ask Wolfram? Is that what it is? I never used this before, so I'm not sure. No, we're looking at the wrong thing. How do I use Wolfram? I feel really dumb about this. That's their homepage. Oh, here we go. Is that it? Wolfram Alpha. That's where I am, yeah. Oh, did it reduce it to me? For me? Where did it get that 13/50ths? Oh, you're saying it maybe doesn't understand the modulo? Well, I mean, that's okay. 13/50ths. Where would it... I think it's because it's misinterpreting that to be a multiplication. It's because it thinks it's a percent, right? I think it's misinterpreting the syntax. I think it uses mod, so I would say mod here. Solve for me. Nope. Probably math input. Ooh. No. Nope, I've confused it. Hey, Endurn, are you here? Endurn, wield thy sword. You're not here? Probably in the car, right? Okay. Endurn, they always try to sneak past when you're in the car. Ka-chunk! Oh, okay, so then I can write it, I had to write it weird then, right? Mod 26. And then that, no. I'm trying to write it the way you wrote it, so let's see if I can do it. If figure it out. Nope, still can't figure it out. It's confused. That's okay. Okay, one insight I get right away is that we're always dividing by this first constant. So sometimes we're dividing by 1, other times we're dividing by 26. A equals 1 or 26. B is all over the map, so is C. But A is either 1 or 26. Anything useful I can do with that? I don't know if I can do anything about that. Capital mod? Trying to help Wolfram out. Figure it out. It's trying. Nope. Okay, our input comes in two places. It compares B to that. So the only time it will really, actually never matters. B is never between 1 and 9. So does that mean that B constant's a red herring? Oh wait, no, it's the entire expression. Never mind. It's this entire expression right here. Okay, let's make something else called like D. If D equals that, then I can clean this up a little bit. Maybe make it easier to think about. What can I do with this now? You're out of ideas? Yeah, I've been out of ideas. I'm just trying to see if I can get an aha moment, right? So if we think about it from the end, if we want this to be 0, then that final input, we're going to add that final constant and multiply by the other constant. Look at these numbers. Actually, let's move this to the top. That's easier. So that's A, B, and C. What can we say about this one? It's some number between 0 and 25, and we're adding this B constant to it. And if it's not equal to our input, then it affects... Actually, you know what it does? Since we're multiplying it, it will either add 25 or we won't, and this entire clause goes away. So if D is 1, okay, so that means there are two alternatives here. It's either that or that. So it's either that or that's 0, so, and then that's all 0. And that goes away. Okay. So depending on the value of D, it's either that or that. Okay, so we're either just dividing by the A constant, or we're adding 26, no, multiplying by 26, and then adding the input plus a C constant to it. Okay, now we're getting somewhere, right? Now, how do we know that? If the input is, we're comparing the input to the last output mod 26 plus B. Huh. It does look reduced, doesn't it? So really that's 26 times that. Or another way you can say it is times 26 over A. Oh, and A is 1 or 26. So this means, okay, I have to be careful. So reducing this further, let's put some dashes in the way. So if A is 1 or 26, then means it is either 1, it's either not there or it's times 26. Or it's divided by 1 or 26. Okay. That should help me out thinking about this, right? Yeah, 26 we saw really early on, right? 26? So here are the equations involved, right? Depending on the values of A, B, and C, and the input, and the previous output, then we're either adding the input plus C. Oh, that's another thing we can reduce. So we're always adding C to the input, right? Yes. So this is just an offset. So this last one is just offsetting by some amount. So can't I just remove this constant just by thinking of these offsets and adjusting my input accordingly? I can get them to line up, right? Especially if we end up doing a modulo, but we don't. Where did the modulo go? Oh, it goes into the decision here. So if, yeah, the previous output mod 26 depends on if we do this or this. So actually there's one condition where the output doesn't change at all. That's if A is 1 and this condition is false. If they are equal. If the input is equal to output mod 26 plus B. You know, ideally, we want to trigger this case to reduce it. We want this as often as possible, right? This causes it to explode. This causes it to shrink. This stays the same, and this increases it slightly, slowly, right? Or decreases it, because C is sometimes... No, C is always positive. So this always advances slowly. This explodes it. This one stays the same, and this one reduces it. So we really want to find the case where... We want to take advantage of where A is 1. No. A is 26. So these are opportunities to... These last 4 kernels and these ones in the middle are opportunities to divide by 26. Yeah. So what's the actual problem again? Yeah, there it is. Largest, yeah, we need to get to 0. That's the whole thing, is I'm trying to get O of n to be 0 when n is 13. O of 13. Goal. O 13 equals 0. Right? And pick the i's 0 through 13 where O of 13 is 0. Given these values for A, B, and C. I need to take a quick break. I'll be right back. Just a minute. Let me just hide the camera for a little bit. I'm back. Just took me a bit to find that button. My window shrunk somehow. There. Just arrived at the office. Yeah, they always try to get us when you're in the car, Enduran. But never to fear, I hit the button for you. Yeah, I am here. So, Enduran, don't know how much you were able to take in while you're driving, just listening to my voice, but we identified that the program that the virtual machine runs is really running the same kernel subprogram over and over again for one time for every digit, but with slightly different numbers for 3 variables, 3 hidden variables. And reduced it down to how, like, the relationship between the output from one stage to the next, if you think of it as 14 stages with different constants in there, to go from the previous to the next, it's either carries through exactly or it's divided by 26. And this is what I'm aiming for. We want to use those opportunities to reduce the number to 0 if we can. Because anything smaller than 26 is going to go to 0 here. This case, if we hit this case, then the number at least doesn't go up. In these 2 cases, it goes up. This one, it goes up by some small constant. And this one, it goes up by a lot because we multiply. So we want to avoid this. So the Reddit thread said to kind of identify this and then here's where we could just have the computer solve it for us. We can go through all the possibilities one by one. And that's what I was thinking of during the break, that I can just try all the numbers 1 through 9 for each kernel individually until we get the smallest number. What if I just do that? What if I just have it iterate, find the smallest number, and because we know what the variables are at every point, and we know that we get to the next stage when we get the next input. So let me augment my program to do that. So I need to put a number there, though. What number are we putting? It doesn't really matter. What if we just put it all to ones again? Yeah. I don't really need to see this anymore, do I? All these print statements. We don't need them. That was just to kind of... I was exploring one way of thinking about the problem that wasn't really going to yield anything good. That's the danger that I'm afraid of when I do these puzzles, is going down these paths that are fruitless, that just consume time. Wrong audio source? What? No, I'm not muted this time. It's not me this time, I swear. Yeah, every time we get an input, let's print out what the variables are. So print line. I guess I can just do this, vars. And let's just run it and see what they are. There we go. So what if I have it, what if I have the computer, instead of actually taking an input, what if it just repeats and tries it for all 9 combinations? Wouldn't that be interesting to see? Let's make this an alternate thing, just in case I screw it up. Instead of run, let's call it... What do I call it? Let's call it try combinations. And we'll give it like a position. When it gets to that numbered input, it will just try all the combinations instead of the one we gave it. One other idea I had was, since you have constants and variables, you can set up a system of equations. That's what I was trying to do here. But this is as far as I got. And I don't know how to combine, because its n goes from 0 to 13, right? And so I couldn't think about how to combine that into one huge long chain and to solve it. And then I figured, if there's only 14 steps, and each step only has 10 combinations, we can just have the computer explore all of them, right? And just find the minimum, because we know that if we just avoid these paths where it gets higher, and we just explore the ones where it stays the same or goes down, I think we'll find it. That's what I'm hoping to get this to do. So the idea would be here. We would need to mark... We need to remember when we get to the correct position. So hold on, let's let mute. Let's call this one trial position, and we'll call this one current position equals 0, and we'll say I don't want to structure like this, because at a certain point I want to start looping and printing. So what do I want to do here? I want to say for, well, let PTR equal 0, mute that, whoop, mute, and then while PTR less than self instructions length, with the idea that at the end here we're going PTR plus equal 1. And then this is let instruction equal self instructions PTR. And then I want to remember the trial start. None, because we don't know where it is. And then when we get an input instruction, here's where we like figure out, are we going into the trial or not? So basically, if the trial is 0, that means I want to try all 9 numbers for the first position. If trial position is 1, then I want to try all numbers from 1 to 9 in the second position. See what I'm getting at? And then instead of returning these variables, I want it to return the best number for that position. So that would be a use size. Okay. Or let's just have it print out a character. Okay, so then we can do this. We can say if position equal trial position, then we should just record trial start equals some PTR, right? And then instead of doing this, oh, we should only want to do this one time too. Actually, it'd be better to just say else. This is going to get complicated. I'm sorry. Let me do it from. I'm having a hard time actually explaining what I'm thinking. As we go through, when we hit an input instruction, here's where we're like, we found the beginning of a new section of code, right? So I had done that before by putting a new line. Right, when we hit this, that means we're on to the next block. So we should, when we're searching for the best case for the previous section, we should stop there and then like loop back to the top. And instead of inputting, we just try the next number. Oh, so then actually that's what I'm going to do here. Let mute next try equals 0, or the character 0, because the idea is we either are going to do that or we're going to try next try. So if we hit this, that means let's just throw this away. So input skip, right? And skip 1. I guess that we just call next. That's the same thing. Yeah, actually we do want to call next. Skip wraps it in another iterator and doesn't do anything until we call next. Record where that place is. We're not going to print the variables here. Yeah, otherwise we're going to do this. Okay, so then instead of doing that, we're going to set it to 0. What's this var? Can't be dereferenced. What? How did that change? Oh, because we need to borrow that. Yeah, my bad. All right. Okay. We should check to see if we're in the trial area. So I guess what we'll do is just say if trials, else if let some start equal trial start. Then increment it. So mutate that. Start plus equal 1. Actually, here's where we want to print this out. Oh, if we go back, I need to remember what the state of the variables were too. You know, this would be a lot simpler if I just printed out all of them. No, but I can't. I want to use this in an outer. Okay. Again, having trouble explaining what my brain is coming up with, which maybe means that I'm not thinking clearly, but that's okay. Actually, the way that I'm envisioning that it would solve this is it would start with no input. And it would just churn through the first set of instructions over and over again. So the non-reverse engineered, where is that? I closed it again. I shouldn't do that. I think I closed it because I kept touching it. Oh yeah, that's why. Yeah, so don't touch that. Go to this one. Here, right? We will go through this over and over again, 1 through 9, and find the best number for z. Find the smallest number for z, right? And then does it even need to be the smallest number? Yeah, I guess we can try it for the smallest number. The smallest number that goes with the biggest input, maybe. Well, we'll see. And then when it finds it, then we'll start over again, but we'll use that answer for the first one, and then we get to here, we run this part over and over again. Actually, I guess we can run the entire program over and over again. That's how I'm going to do it. If we run out of input, then we're going to cycle through 1 to 9 to find the next. That's what I'm going to do. Okay, so then I don't need a trial position. So it's just when we run out of input. So I don't need this. Let me just start over here. Comment that out for a second. So let's do it this way. If let sum next input equal this, then it becomes next input as u8 minus b as u size. Otherwise, here's where we need to start cycling, right? So we'll say if let sum trial start, well, if trial start equals is sum. Actually, I don't need to know this, do I? Then we can return this, actually. Why not? I think if we just return early. Go through the else first, because we started at none up there. So what is it? It's trial start equals some position. But some PTR actually. And then I have too many variables. Let's delete this for a second. I don't know what I meant for that. Okay, I'll need to remember the variables as well. So let's say let, well, yeah, at this point we would loop back. Pointer equals, oh, then I can just get this, right? Let sum, I don't know, position equal trial start. Then pointer equals position. We're looping back at this point. And then, well, either way we're doing this. right? And we're incrementing next try. Next try, actually I don't need it to be a character then. This can be an eye size. Next try plus equal 1. If next try equal 10, then we're just going to return the variables at this point. So that's this stuff. Or, no, I want to return the number which was best. So we need to record the lowest. Let mute best equal none. Return best unwrap. Yeah. Okay. So let me think about this. This is hard. I want the position and the vars start because I want to reset the pointer and I want to reset the vars. I have no clue how to really solve this. I have sort of a clue, but it's hard to put into words. So I'm trying to put it in my thoughts into code. And if I have the wrong idea, then I'll find out by this not working. What's this problem? Oh, this needs to be a tuple, I guess. So the first time through, we'll be actually reading our real input until we run out of input, at which point this trial start won't have started, so we'll go into this else. So here's where we want to just record okay, and I don't need to do anything there. We want to record the pointer and the variables at that point. So when we get to the next instruction, actually if we get to the next instruction or the end, how do I handle the end here? That's a tricky one. Can I just insert an artificial last loop at the end? I feel like I'm doing this wrong, that this next try should go outside of this function. Yeah, it should go outside this function. I don't know what I'm thinking. This is stupid. We don't need to do this. I don't need that. I don't need best. Well, I don't need best. I don't need any of this. I can do this a different way. This should just do, yeah, here. If we have some input, otherwise we're going to return immediately. Where did I put that code? Yeah, it was that, right? So just return it. Just return the variables at this point. This thing down here. A break would do this, right? Can I break? And then I can put this the way it was before, which was this. I can break out of a for loop, right? I don't need this. Okay. So basically, if there's not enough input, we'll just break early and return the variables as we are. That way we can just start with a string of 1 only, and then we just run the first kernel, and we see what the variables are. And we just run it 9 times. I don't need a pointer plus equal 1 there. Okay, so this is what we're going to do. We're going to say for n in 1 to 10, or we can do inclusive 9 if maybe easier to say. Let vars, I guess, equal monad run n to string. Borrow that. And just print, let's just print them. N and vars, right? Let's just see what we get. Vars, I cannot print y. Tuple doesn't implement, okay, we'll just do a debug then. Okay, let me just see what this does. So this will be all the variables from for the first one from 1 to 9. Okay, we got an unwrapped none on 78. Oh, right. I'm calling the wrong thing. We don't want to call run. We want to call the other function. Try combinations. Well, let's rename that. Let's call it try. Well, I can't call it try because it's a keyword. Try run. That actually might turn into run when we're done. Okay, here we go. So we see that the best number is to start with 1, I think. But let's try position 2. Let's try 1. Let's call this n0, and then we'll have like, well, this is n, that's n0, right? And then we'll have for n1 in 1 to 9. I think I want to reverse these actually. So what I end up doing here is let input equal standard iter once by b0 plus n0 chain with another iterator for the next n1 collect as a string. And how come I can't? Oh, because these need to be converted to characters. And then it's just n. Input, not n. So I'm disregarding the old input. Really, this is source, right? There we go. So this is just the variables after the first 2 digits, right? And that kind of confirms my suspicions that Z is the lowest for 1, 1 because of those constants, right? But when we get to the 4th one, there's our opportunity to divide. It's that Z that's the one that carries over, right? Let me do this again with 3 digits. Okay. Yeah, so is there any reason why I would use anything other than 111 to begin with? I think we'll start to see it when it goes to oh shoot, I've closed it. When we get to the 4th digit, right? Because that's where we're going to start to divide by 26 possibly. And then, so maybe the biggest number is 1, 1, 1, and then some number that lets us divide the furthest. So yeah, one more level, and I hope to see it at this point. Okay, there we go. Start to see it there. I think we can just take the smallest, but I'm not sure. Maybe I can try to find the smallest. Let's do that. So let mute smallest equal none. If let sum smallest equal smallest, else smallest equals sum input and vars dot 2. So if vars dot 2 is less than smallest dot 1, smallest equals sum smallest. Why is it an option of an option at that point? Because of this, I think. Wait. Oh, I can't do that. I'm shadowing it when I do that. How do I do this? Previous smallest? This should just be smallest. That's where it's getting in trouble. No, I should just... I have an error somewhere. I just need to do this. String I size. Okay. It's both of these. Okay. Yeah. Expected tuple found enum. Oh, yeah, this should just be smallest. Yeah, because of the shadow. 4, 4, in 4, 4. Yeah. At this point, I'm still experimenting. Yeah, it looks ugly. Sorry. Oh, I never actually printed it out. Print smallest. Smallest. Let's look at that out.txt. What is the smallest? Smallest was 1131. So that's what I was thinking. That, well, actually, no. I thought it would be 111. Why is 3? What's up with the 113s? Interesting. It must be because of that constant that's in there. I keep closing the file. Why do I do that? What would be about 3? What is it about 3 that... I can't see the two things I want to see at the same time. Is it out? Yeah, I need... Don't close out. Don't close out. So for the third one, a 3 ends up with a lower output. Why? B is 12 and C is 11. 1 plus 20. Oh, because of this? The previous output, mod 26 plus B, is not equal to the... So the input being 3. So it must have been that... well, hold on. Maybe I got that wrong. Maybe it's not... Maybe that's the wrong equation there. At one point, it did have 14 nested loops, and brute force attempt made it through about that many values in 4 days. I would think it would be the heat death of the universe. I'm having trouble seeing how these, like that 11 and that 12, could make a difference between 2 and 3 for the output there. But maybe because I'm considering, because this is not showing me what 113 gave us, right? I need to see that. I need to see those intermediate ones. Let's print those out somewhere. Actually, I guess the way we do that is to just run this one time without N3 in it to see that. That's an easy way to do it. Muscle memory, I think, is causing me to close these files and I've been looking at them. Okay, so 113. So it's something about these numbers, but I'm not getting that. Oh, it's if the modulo 26, how much do you want to bet that that mod 26 is 0? Where's my calculator? I closed it. 1626 divided by 26. 1625 divided by 26. 627 divided... 1627 divided by 26. Oh, is it mod after adding some offset to it? No, it's literally the previous output, mod 26. Well, what am I missing then? 62 times 26 is 16, okay, plus 26. Then I'm missing something. That's nowhere near, minus 1626, 12. So 1626 divided by 26, 1626 divided by 26, 62 times 26, 1626 minus 6. I can't do this math. This is hard. 62 times 26, 1612. 1626 minus 1612, 14. 14 plus B, which is negative 13. Is that it? So that will match the input for a... Okay, I think I see where this goes. Did that by doing division, subtracting the whole part and adding. So... Okay, this teaches me I can't just pick the lowest because it would have picked 111, and then we would have missed the best, which was 111, which was 1131. So I can't just do it one digit at a time. Do you used to see Spider-Man in your childhood? No. I didn't see Spider-Man in my childhood. I don't even know what that question means. But hello, Ravi. Maybe I wrote this down wrong. So that handles the 1, this handles the 1, and this one handles a 3. And this one handles the number after the 3. Oh, it's the next number after the 3. It takes the previous one. Okay. So we won't know until the next one if the current one is good. A good path. So then that means I need to look ahead too then. How to earn as programmer. Any tips? No, I don't have any tips. Sorry. I don't know why you're here asking me how to earn as programmer. This stream has nothing to do with teaching you how to earn as programmer. We're doing Advent to Code. Yeah, you might as well just ask me how do you earn as worker? Go work. So how to earn as programmer? Go program. Learn how to program. How do you learn how to program? Go to google.com, type in learn programming. I'm sure you'll find something. We don't need that anymore. Yeah. Let me give you one piece of advice. So if you want to learn, don't just say how to do something. Do some research yourself and then find 2 or 3 things and say, is it better to do A, B, or C? Yeah, the question how to earn as programmer is a low effort question. Put some effort into it first. Right? If you were to say, is it I've looked online and it looks like people learn JavaScript, people learn C++, people learn C#. Which one's better for earning money or getting a job? And then we can get into well, what can those language skills get you, and what are you interested in? Do you want to do web programming? Do you want to do game development? But starting with something like how to earn, I don't know what to do with that other than to presume that you might be trolling, and then my mouse button starts to hover closer and closer to that ban button, and I don't want to press it. You know what I mean? I'd rather have a constructive conversation if I can. People 99% don't know what to learn because they don't see it. Start with something you want to do and find other people that are already doing it maybe and say what you're doing I would like to do, how did you get there? And then they'll say, well, I did this, this, and this. But if you start with an open-ended question, how do you be a programmer? I don't know what to tell you. I don't know what you want. All right. Anyway, back to the problem. I have a feeling I'm not going to get to enough time to play Valheim tonight. That's okay. This is hopefully the last hard problem this year. I'm being pinged. What if I just expanded this more? Okay, I think I need another hint. This one said, extracting the constants that were different for each input edition. Used Z3 to solve for a satisfying set of digits that result in a final Z value of 0. Use Z3. The solver many more times, progressively constraining the digits from left to right, finding the maximum or minimum satisfying digit for each position. I don't know what the Z3 solver is. What's a Z3 solver? Maybe that gives me, maybe that's all the hint I need. What is a Z3 solver? Tomorrow's question, give the sum of the current year plus the current day number. Print line 20211225 solved. A cross-platform. Oh, so this is just like something that will solve a bunch of equations really fast. Okay, that doesn't really help me. Yeah, we already figured this part out. Also notice that we only ever add a positive number or divide by 26 with rounding down. Somewhere each block this way. This is probably what I ended up with, right? Brute force search should actually run in a few seconds. Okay. They vary from block to block. What are we searching for, though? I think that's where my brain is not connecting to this. Avoid it blowing up. Yeah, I thought about that, but having your input character be equal to the z from the previous stage module 26 plus the ax for the stage. Wait, only consider that value for w instead of the whole 1 to 9 range. Oh. Avoid the multiply whenever possible. Yeah, that's what I was thinking. So that was the condition where where was it again? It was this one, where d is 1, where these are not equal. Oh, okay. Yeah, okay. But we'll know immediately if we blew up, and we can just skip that one, right? Let me look at the output again. I guess we don't see that on the first 3 numbers because A is right. Oh, that's right. The fourth one is the one where we can actually go back down. So yeah. Where's the multiply by? Okay, it's there. How come I'm not seeing it here? I'm not seeing any explosions by factor 26. I guess we are seeing it actually. But they're unavoidable? Oh, right. They're unavoidable because for the first one, it's always going to be not equal to. So we're always going to explode a little bit on the first 3. But the point is to when we hit these, to find the smallest again, or to prune it. Oh, I see. Okay, so we can consider all 1,000 possibilities here. When we get to here, though, we want to pick the lowest. And then do 2 more digits. Then for this one, we want to pick the lowest again. For this one, just take all 9. And for this, find the lowest again. And then on these, find the lowest each time. Okay, can I do that? So encode it as literally, that's the 3, 6, 8, 10, 11, 12, and 13. I still don't know if I can do this. People see a website and want to become programmers, but have no idea what a function looks like, what rounding a function looks like, what namespaces look like. This is a difficult topic. What very spoilers, someone did a write-up. Yeah, I'm trying. That's Eric. I'm trying to do this without too many spoilers. That's why I'm like, I'm reading a little bit more in the mega thread, and I'm like, if I see something new, I'm like, okay, let me think about that. Does that give me that last piece of information? And so I read this part: avoid blowing x up by 36 by having your character be equal to the z from the previous stage modules plus ax. Ax. The 1 plus C modulo. So that's the okay, what they say A is AX, I'm calling B. So plus B. Right, if it's equal to, yes, okay. That's true for every stage? Okay, I see. But that means I have to have extracted these B numbers out. When the necessary W value is within our 1 to 9 possible range. Oh, when the previous output modulo 26 is within 1 to 9? I see. Yeah, because if it's outside 1 to 9, well, plus B, then we'll guarantee blow up. Yeah. So do another 11 puzzles before getting to this day? See, if we can get it to finish within a minute, that's good enough. I mean, when we get to this point, we could just try all 9. That's what I keep getting back to what I was thinking before, is we just try this, we find the smallest. Okay, out of curiosity, what does it get? At some point this breaks down, right, where it just gets impossible and possibly complex unless we start discarding discarding whole trees, right? Okay, that's already taking a noticeable amount of time. The bottom will tell me. 11311. Really? I wonder if these are the best numbers so far, or do we really have to carry it all the way out to the end to know for sure? Well, the best we can do is end up dividing by 26. Doesn't that put an upper limit on how high our intermediate numbers can go? The top of this. If it needs to be 0 at the end, it can't be any higher than 26 before the last step. Can't be higher than 26 squared, 26 to the third, 26 to the fourth, 26 to the third, fourth, third, fourth, third, second, third, 26 to the third power, right? Yeah, do that right? 17,576. Can't be higher than that. But what were the numbers we were seeing? Not that high. So we can't discard any paths yet. Met, I'll allow it. What are we allowing? I don't know what we're allowing. Okay, back to the hints. I don't like this because I don't quite understand the language. Let me try a different one. Cursive sweep to the model space while memoizing on the current register values. Basically, if the model number parts are red, they don't matter for the recursion, only the state of the... Oh, that's true. But doesn't that space still explode to be a large space? You hear that, Eric? You like to punish us. Hey, this looks like my solution so far. That's day 19, day 18. How did I get to here? I'm supposed to be on the mega thread for 24. I guess the mega thread's not that mega yet. What if I refresh? Okay, maybe we're onto something here. Increases. This is what I figured out. Now, how do I get from here to his solution? The condition to decrease is always a comparison between the two inputs. The fourth increase, okay, since to get to 0, assuming everyone's program has 7 absolutely increasing in 7 conditional sections. 1, 2, 3, 4, 5, 6, yes, 7 absolutely increasing, and then 7 opportunities to decrease, yes. So we have to satisfy every, that's true, we have to satisfy every decreasing condition, okay. And I'm just deriving all the conditions by hand. Interesting, okay. So we have to know which steps we're looking to decrease and just find the one that decreases it, I think. So I have to encode these positions. And at that point, we just pick the smallest. And that's how we reduce our space. Okay, then I think I know what to do. Get rid of this. Okay. Then it's going to necessarily need to be recursive. So solve with nothing. To owned. Function solve. This needs to be given the monad. And then input. So let position equal input length. If position, what's the best way to encode this? 3 or position equal 6 or position equal 8 or position greater than 9. Let I'll just hold on to that as a boolean for now. Opportunity. Okay, so then for next in, or for n in 0 to 9, or 1 to 9 inclusive. Oh, this needs to return something, by the way. Usize. Because we want the smallest. we want to know the actual input and then the value of the output for that. Yeah. Okay. And we want to do from 9 down to 1, right? So reverse. Smallest equal none. Next input equal input.chars chain standard iter once be 0 plus n as char. Collect into a string. And then let input this is not, well, complete input solution, well, candidate, and output equal solve monad next input. If let sum previous smallest equals smallest, else smallest equals sum candidate output. If previous smallest dot 1 is small, if output is less than previous smallest output, smallest equals actually this goes there, else this goes here. Right. We only want to do this if it's not an opportunity. So if opportunity, else that. If we have an opportunity, we actually want to not call solve, but call try run. This is not going to help me. Oh, it's monad.try run. Monad.try run. Next input. It's not candidate output. It's we only really care about the third argument, right? So output. We're going to get rid of that. Iter? Into iter? I thought range is already an iterator. I think there's something else wrong here. Yes, borrow there. And that can borrow there. Solve should return smallest. So Smallest unwrap. Why can't I reverse my iterator there? Why is it giving me this trouble? Oh, because this needs to be put into parentheses. Okay. Annotations needed. Why you need annotations? I don't understand why this needs an annotation. That's a U size, and so is that, right? I don't know what its problem is here. Okay, I guess I need to assign it option string U size. Okay, I don't know why it needed that. Oh, so this was 0. There. Okay, this is why we had trouble, because this needs to be mutable. Right, so let the output be that. And if, yeah, it's this right here. So did I actually use candidate? I did. Candidate was the string. Hold on, what is the string it's giving me? I don't know. Smallest. It's the entire input, it's what it is. So I think I'm programming myself into a corner here. This is also redundant. Yeah, this should just be let output equal this dot 2. Otherwise, it is oh shoot, no, I'm doing this wrong. Dang it. If you make the room round, are there infinite corners or no corners? There are no corners, Andoran. It's one of those days. I should have known. I should have known this would be really hard for me. This must be tough to watch. How come people are still watching? I've whittled away all the people that are not like hardcore watching me to the very end. 3.5 hours later, finally getting part 1 down. Background sounds, yeah, that probably. Everyone who's actually hoping get a solution is probably left, and now it's just the background noise people. Your colleagues are either off or working remote, yeah. So I am now your colleague. It's good to be your colleague, Andoran. I'm trying to put my thoughts into code, and it's not coming out. What it is if we're at this position in the input string, we have the opportunity to just discard all the paths that don't give us the smallest. Otherwise, we have to consider all of them. Yeah, so that means that this, I don't need to get this, no, I do need to get the smallest, but not at this point. Yeah, I don't need to do this. It's just this. It's just solve. No, there's still a loop. There's still a loop. Hold on, let me think about this. I think the problem is I have this backwards. I do. I totally have this backwards. So the outermost loop should handle the possibilities for the first character, right? So that means at this level, yeah, we've taken one guess for the first character and then said solve for the rest. So then, that's fine. We do want to find the smallest at that point. So try 1, try 2, try 3, try all the way up to 9. Pick the smallest of those, right? So for when we do have the opportunity to pick the best one and not try them all, what do? Oh, right. Then I don't do solve. I just do try run. Yeah, okay. Got it. And then when we do try run, we pick the smallest and then we solve, that we call solve again with that string. Okay, so let me see if I can do this. So yeah, I need to take this out back again. If we have the opportunity, then actually then this I need to pull this out, don't I? Yeah. Pull this out. There are actually two inner for n 1 to 9s. Like that. I need to put this for also down here. Thank goodness for Rust formatter. So this is the, yeah, I guess we can, yeah, I need to do this too. I'll fix this up later. There's the redundancy. So for the first digit, we try all 1 to 9, where we just add our next digit to the end of the input. We chain it to the end. And then we recursively call for the rest of the digits, so we just pick the smallest one. If we have an opportunity to pick the smallest first and then proceed, then we're doing a try run and picking the smallest of those. So yeah, I just need the smallest output here. So this smallest can go into here. This can go down there. All right. So here, let smallest equal none. And I just need to know the number, right? Yeah, I just need to know the smallest n. So if next input okay, so when we find the smallest, then we just call solve once for that smallest. And it's not next input, it becomes smallest 0. Okay. So this is next input. Still have a problem right there. It needs to be annotated. Option string usize. Because why? Because this is completely wrong. Oh, we can unwrap it. Unwrap 0. Well, let smallest equals smallest unwrap. Then take the 0 out, the first one out. Okay, what's wrong with this? Oh, right. It is an ice size, isn't it? Okay, and then this just needs to be mutable. Okay. I shouldn't need that. I do need that. Why do I need that? I don't know. We'll leave it in there, though. Is this right, then? So, if this condition is true, then we're going to, for all numbers from 1 to 9, take a previous input and tack the 1 to 9 on the end, and then do a try run to that point. And then if we find which one gives us the smallest output, and using the input for that, we just solve for the rest. I think that's it. So then what should I print out at various points, like trying or something? We can print it here. Print trying input. So it shouldn't have to try them all, right? Okay, how do I call this solve? Oh, I'm already doing it from there. So I don't need the smallest. It's just that. So then run it. Here goes nothing. Overflowed its stack. Okay, I messed up the construction of the strings, obviously. That's entertaining. Look at that. It's only supposed to stop at 14. Okay. We have to stop it at 14 characters. Yeah. So... yeah, it's here. If position is 14, else continue. We know it is. It is smallest. Expected a U size, so those should have been a U size all along. So how did it get to be an I size? Try run returns an I size? It does. Okay, that's because... I mean, I guess we can assume they don't go negative. Is that a safe assumption? I think it is, so then I would say let output equal output as use size. What's it telling me here? Oh, indeed. Can do that. And then running it again, what do I get? Nine, 7. Here's where the first opportunity is, right? So it figured out... Okay, maybe I should just let this run without printing then. Just let it run and maybe it'll find the best. So if I wasn't printing, it probably would find the best. So let's remove the print. Run, little program, run. CPU goes brrrr. I know, nice space heater I have here. I wonder if it'll actually find a solution. Probably run in release mode. It'd be nice to kind of get a hint, like every second have it print out where it is, but that's okay. I don't think I got it. I think this is just too slow still. I could print it out here. Still printing an awful lot, isn't it? How about we just have it printed if it's in position 4? I should have done that from the beginning. If position is, or 3, really. It's when that gets down to all ones, it'll be done. That'll only take a couple hours. It just needs to tick down to all ones. So I just didn't wait long enough. So this will actually hopefully get a solution when it gets down to all ones. That's going to take a while, isn't it? Is it time to get another drink? It's past midnight for me. It is single-threaded. I don't know. If part 2 is not so bad, then I could live with this. I mean, if I'm just a little bit patient, we're almost halfway already, right? Time to hydrate. Hey, we're almost halfway. Yay, we're halfway. Maybe while that cranks along, I can look and see if there's some other insight. Oh, being rated by losing really badly. I'm losing this contest really badly, so you and I have something in common. How was your stream? I'm trying to solve the Advent of Code 2021 day 24, and it's kicking my butt. Hello, Regal2K. Gonna try to clean up your code after you wake up. That's one approach that I could take with this too. I could just say, hey, let's just put this on the shelf and come back at it tomorrow or after Christmas or something. Maybe I'll get an aha moment between now and then. But if this actually gives me the right answer after finishing, and I'll be okay squeaking through with brute force. Okay. Is that the answer? We might as well give it a try, right? Nope, it's too high. But is that what they actually asked me for? That is what they asked me for. 9, 10, 11, 12, 13, 14, 15. No. 7, 8, 9, 10, 11, 12. That's a 15-digit number. I went too high. Okay, that explains it. We want to stop at 13, not 14. It's probably that with the last digit chopped off, right? It's off by 1 digit, as in it's really that number, right? But I have to wait a minute. Weird off by 1, yeah. I did a 15-digit number, not a 14-digit number. Actually, it has to be that number, right? Because the program would have ignored the 15th digit. Yeah, there we go. We got it. We whimpered through part 1. Let's go on to part 2. As the summary starts booting up things like retro and cabulator, you realize that maybe you don't need all those submarine features after all. What is the smallest number accepted by Monad? Oh. Okay, we can do that. Yeah, we just reverse it, right? So I just take that off and do that. Is that right? Yeah, yeah, because we'll get the first 0, right? Here we go. Smallest number. No, it's still counting down. What did I do wrong? Oh, I did, hold on. There's 2 places we have to do it. Down here too. All right, smallest number. Reverse, reverse. Reverse! Reverse again! Okay, I'm okay. If this gets me through Abinacode 2021, I don't mind that it's taking like a minute. I can like take a breather, I can hydrate, I can check this code in and never look at it again, and I'll be happy. Woohoo! Eric, you enjoy torturing us, don't you? No. Favorite thing that I read about Abinacode is that, what was it, a Twitter discussion, and it was like a long list of things, and I think Eric responded with, what I hear from you is that you learned something, so that's good. You have to disassemble your brain so you can pick it back up, yeah. So what did I learn from this puzzle? That, well, number one, I learned that I picked out the 26 right away, and so I can kind of see patterns, but I can't quite get to an optimal solution here. But I felt like, just like on day 22, I think it was, I was on the right track. It's just that little bit that to get me to the end that I'm missing. So I'm learning my own limitations here. Solution is nearly 450 lines of code. So how long was mine? I had a lot of lines I didn't need. Like, we never needed to have a separate thing for part 2. I didn't need the actual run at all, so I might as well just delete it. We just need to try run. I ended up encoding my input partially inside of the solver here, right? So here's the smallest number. Let's make sure it's 14 digits this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, yes. Yay! We did it. We did it, chat. Okay, how did everyone else do? Oh, wow. I got a pretty good rank, even though it took me 3.5 hours. That's comforting. So I'm still I did okay for me, I guess. Yeah, we should look at what did people get. Okay, that's just cruel. Someone did this in under 15 minutes. Yeah, so there was a fairly wide spread. So if like you took an hour to do it, you would still scored some points. How did... Oh, Jean-Noel is like, oh, quick, I just need to reverse that and run it again. And it took them, what, between 14 and 47 seconds, like 30 seconds to run it a second time. No, we didn't get. We're not going to get sub 100. Ryan was a sub 2,000 person. How did I do compared to? So Eric, since you're listening, my pet peeve is that I have to get to leaderboard to see my personal stats. So when I think of personal stats, I always hit stats, and I'm like, oh yeah, it's leaderboard, then personal stats. If stats had a personal stats, then I wouldn't get confused. But you don't have to do that for me. Yeah. Thank you for the follow. We keep telling him this? Yeah, you have in your notes to rename personal stats to personal ranks or something. I think the problem is that these are ambiguous, right? Leaderboard and stats kind of like are in the same realm of things. Anyway, I'm sure you've thought about it a lot more than I have. And the position thing when you start later? Oh, yeah. I'm sure Eric's heard of that too. Another thing that I have a problem with is on some days I can't start at midnight Eastern. So what I'll do is I will start a day later, and then I always think it would be cool if I could record my own time and then like figure out, like enter a time and say, well, who got a time close to that point and what was their rank? Because then I would have known what my rank might have been if I had been able to start on time. Not have it count officially here, just for my own satisfaction. Like, I don't know what rank I got there because let's say I started exactly 23 hours late. Then I would have to have some way of entering the time 41 minutes, 58 seconds, and find out what my rank would have been. So the closest thing I thought of was, without data mining the thing, is to poll people and find someone who got around 42 minutes or 41 minutes and say, well, what was your rank? Oh, you were ranked 2,000. Okay, that's the rank that probably I would have been. So we were speculating, would that be difficult or hard on the server? Maybe we could be allowed to enter a time one time only, and just to get an unofficial rank that we can see. And then after that, you could just not compute it. Or maybe it's a simple lookup and it's no big deal. I don't know. Anyway, it's not my place to be asking for features. Advent Code is super cool. I have a super fun time, especially when I don't rage quit. And I should probably wrap things up because I need to wind things down. The passage just dumped a ton of stats you could use for this. Oh, okay. I mean, that's offloading the work so your server doesn't have to do it, right? Yeah, it's just kind of like, it would be nice to know if this was a good day or a bad day or an okay day compared to the other days. Also, I think the rank itself is a little bit misleading because really I should be, if I'm doing the same performance, my rank should be going down as we go because there are fewer people, right? Because I was thinking, it's not just that people stop after the first few days. They also get more difficult. So there are many variables that go into that. So I'm not sure how meaningful that is for me personally, that number. Like, the only meaning I could have it assigned to is if I was competitive, which I'm not really. I'm not competing with anyone else. I'm really wanting to compete with myself to say, did I have a good day? Did I have a bad day? Sometimes it's obvious, like I think it was, day 7. I started on time, got a horrible rank, and I knew it because I totally fell on my face there. Yeah, giving people the data so that they can calculate it offloads it from your server, so that's a good idea. If you're not competitive, rank isn't meaningful. But I'd like to know if I'm competing with myself. Like, I guess I just poll myself. Did I feel like I had a good day or a bad day, and leave it at that, right? Yeah. Anyway, enough of looking at my stats. I wanted to go here because I wanted to look at private leaderboard. And yeah, T-Bod. I'm not going to beat T-Bod. Endurin is on day 11, like you said. Is Primogen near 69 still? Ooh, he's one away. I should taunt him. He would enjoy that. Okay. So, anyway, we're almost at the bottom of the ocean. In 20 and a half hours, we'll be able to see what it looks like. Let me find someone else we can go watch for a while. I shouldn't be monopolizing your time, right? There should be someone else who's struggling with this. Let me go to Browse, Creative, Software Game Development. Okay, that's nice to see. I'm at the top, except for a few trendings. Let me search admin of code. There's no one else streaming admin of code? I'm the last one? Come on, there's gotta be someone else. It's gotta be someone else. Okay, not admin coded. Let's just go look for something interesting to watch. Oh, let's learn Rust Day 1. We need to raid this person. Okay. This one oh no, they're not streaming anymore. Or are they? They are. But I'm watching an ad. This is confusing. Are we watching it live or not? I need to refresh then. Oh, I guess they just quit. Oh, and they were learning Rust too. I would have liked to raid them. Someone's doing a parser in XML. That looks fun. Epsilon and Woo are still going? Okay. How come they're not showing up on my list? Are they not streaming under the same category? Okay, I'll just have to type it in manually. Epsilon 1. Because Twitch search is literally the worst. I don't disagree. Oh, and Aneurysm's already over there. Okay. Don't spoil the raid. We'll raid Epsilon, who is still working on day... There we go. Okay, I think I typed the right command. Okay, thank you again, Aneurysm, for letting me know about Epsilon 1 still going. We'll raid them, and yeah, don't spoil the raid. I don't know if I'll be back tomorrow. Maybe I will, but it is Christmas Eve. We'll see. To finish admin of code. But in the meantime, stay safe, have fun. See ya. Thank you for watching.